Hi there, my name's Charles Martin. I'm from the Australian National University and I'm here to present this research, Sonic Sculpture, Activating Engagement with Head-Mounted Augmented Reality. So my co-authors on this project are Zero Liu, Yichen Wang, Wenan He, and Henry Gardner. And my co-authors are also associated with Data 61 at CSIRO, or the Commonwealth Scientific and Industrial Research Organisation here in Australia. Now in this research, we aim to explore how a head-mounted augmented reality system can be used to present a sound artwork that accompanies a physical sculpture. I'm going to talk a bit about using AR for a sound art installation, a bit about our particular piece, and the two different interaction modes which we designed. Then I'll talk a bit about what we learned developing and testing this work. So there's been many different sonic artworks created as part of sculptural installations or gallery exhibitions, including many discussed and shown here at NIME. Broadly, there's two technologies used to get the sound to visitors. First, mobile devices. We know that you can develop amazing sonic art pieces and interactive music systems with mobiles. The great advantage here is that every visitor will have their own experience, and you might be able to use some of the mobile sensors to help drive the sound. And of course, many artists simply place loudspeakers around artworks to deliver sound to visitors. This is simple and effective, but everybody has to hear the same thing, and you have to physically install it at the site of the installation. So in our work, we're interested in using head-mounted mixed reality devices, such as Microsoft's Hololens, to deliver an interactive sonic art experience to individual visitors. So these devices have a transparent visor, so that they can display virtual objects within the visual field of the wearer. They're loaded up with cameras and sensors to figure out where they are in an environment and what the wearer is looking at. They can track your hand gestures so that you can interact with virtual objects. And they have speakers in the headband that work quite well to provide sound to the wearer. So compared to phones, the HoloLens has more capacity to be spatially aware. Our interactive system can then be aware of the wearer's location, where they're looking, and what they're actually touching. And compared to a physical system of speakers and controllers, we can build a HoloLens interaction with no physical components, and in fact just add this secret layer to an existing environment. Now, we wanted to explore how we could use the HoloLens to create an interactive sound artwork that would accompany and surround an existing piece of public art. And we had two goals with our design. We wanted our system to reveal a hidden interactive sound world around an existing part of an everyday environment. So the HoloLens will let us place virtual objects and sound sources around this physical sculpture for visitors to explore and discover. Secondly, we wanted to explore how this might actually activate engagement with a public sculpture. So I think we've all had this experience with public art where it fades a little bit into the background of our everyday life. And this is particularly the case if the world is changing around an artwork. So this was kind of the case with the sculpture we were working around. So this sculpture is called Il Grande Ascolto, The Great Listening, and it's by Arnaldo Pomodoro and was created in 1968. It depicts these two bronze cones, which kind of recall radio telescopes, listening in to radio signals in this era of digital communications and the information age. So this sculpture actually has kind of a curious history. It was placed outside the old CSIRO headquarters in Canberra in 1970. And it stood there until 2014 when someone actually stole one of the cones. Luckily the cone was recovered, but the headquarters was moved and the sculpture ended up being placed inside a new CSIRO building, but it's actually kind of hidden under the stairs and doesn't have the same prominent position that it used to have. So the sound artwork was created to reflect the idea of listening to different worlds in the sculpture's location. We developed 3 6-minute pieces from field recordings, which would serve as layers for visitors to explore. The first layer was of the natural world around Black Mountain here in Canberra, which is where the new building was located. The second layer was of the human environment around this new building and the Australian National University, again near that location. And the third layer was the hidden radio frequency world of computers, which I recorded with telephone pickups from my computer on my desk at ANU. The idea was that visitors might be able to hear these 3 different sonic perspectives on the sculpture's location and to play with mixing between them while engaging with the sculpture itself. So we developed 2 interaction models for this work in order to test out how we could best use the HoloLens in this context. These were developed in Unity with Microsoft's Mixed Reality Toolkit. First, we created a mixer user interface that visitors could manipulate to control the sound layers individually. We also created a locative interaction where each sound file was placed at a different location in the room, and visitors could mix them just by walking around. So I'll show you a little video about how this looked in practice. Now, we've done informal trials of our two interaction schemes at the sculpture during our development process, and I'm going to talk a little bit about the design issues and practical concerns that popped up during development and these trials. So for the UI mixer interface, we experimented with a few locations for this mixer. I thought it might work well on the plinth in front of the sculpture, but because of the field of view, it was a bit difficult to see, so we placed it on the floor in front of the sculpture. This meant that you couldn't actually see the mixer and the sculpture together with one eyeful, so it kind of felt a bit disconnected. The HoloLens hand tracking turned out to be a little bit tricky for some users, and although I would normally use a fader up and down gesture, that was a little bit difficult with the field of view of the HoloLens because your hand would run outside the field of view. So it was actually easier to go on the side and then use this left to right mixer interaction, or I guess DJ style mixing. So for the locative audio interaction, we found that this was easier for some users to explore because you didn't have to use hand gestures and there were clear markers to guide the user to interesting locations. The audio was actually more convincing in this interaction because the audio sound files were spatialized from these locations in the floor, which you could stand right on top of them. So you had a nice feeling of immersion in the environment. With the mixer UI, the audio came out of the sculpture itself, or appeared to come out of the sculpture, which wasn't as convincing. So in terms of engagement, visitors needed to view the sculpture from 3 sides to explore it, which was good. And when they were at a marker looking at the sculpture, they could also see 1 or 2 of the other markers, and that was also good. So I've told you about our mixed reality sonic artwork developed to go around this piece of public art. Now, it seems to us from this experience that the locative interaction was the most promising in terms of convincing experiences in this hidden sound world. It also seems promising in terms of activating engagement with an artwork that was stuck under a staircase. So far, we haven't found a tactile sonic interaction that worked well with the first generation HoloLens due to these issues with field of view and the difficulty of using the hand gesture pointer. So this system that we put together was practical enough with the HoloLens, but we look forward to continuing our work with the HoloLens 2, which has an improved field of view and much better hand tracking. And we think that this could open up some more interactive possibilities. We also weren't satisfied with the interactive audio tools available in Unity, so we have another project to build a new synthesis toolkit for Unity that we are using in our research currently. So I just want to thank Matt Adcock and Stuart Anderson from Data61 CSIRO, as well as Ben Swift from the ANU and the other students in our Code Creativity Culture Lab. I'll note that this was supported by CSIRO's Science and Industry Endowment Fund. Thanks for listening, and I'll catch you next time.